Imagine giving literally every single employee in a company the master key to the entire building. Think about it. They could just wander into any room, dig through highly confidential files, or even shut down critical systems like the power or security cameras. It would be an absolute disaster, right? Well, imagine doing that exact same thing in the cloud. If you don't tightly control who has access to your data and your compute power, you're essentially just handing out master keys to anyone on the internet.
So, welcome to this explainer where we're going to completely demystify AWS Identity and Access Management, or IAM. We're going to build a rock-solid cloud security foundation from the ground up, and we'll specifically focus on how AI and machine learning engineers use IAM to securely access crucial services like SageMaker, Bedrock, and S3. Because at the end of the day, you need to deploy your models safely without exposing any of your critical data.
Here is the game plan for today. 1. What is AWS IAM? 2. Why AI engineers need IAM? 3. Users and groups explained. 4. Policies and least privilege. 5. The power of IAM roles. And 6. Best practices for production.
Let's jump right in. Section 1. What is AWS IAM?
Okay, let's start with the absolute basics. You can really think of IAM as the ultimate all-seeing security guard for your entire AWS account. IAM stands for Identity and Access Management. It is the service used to control exactly who can access an AWS environment, what specific resources they're actually allowed to touch, and what actions they are permitted to perform. Literally every single time someone or something tries to open an S3 bucket, launch an EC2 instance, or train a massive model in SageMaker, IAM steps in. It evaluates the request and decides right then and there whether access is allowed or explicitly denied. Without it, well, anyone with your credentials could just delete your databases or launch incredibly expensive compute jobs.
Now, this brings us to the two core concepts that IAM handles, and it's super important to know the difference: authentication versus authorization. Authentication is simply verifying who you are, kind of like entering your username and password. But authorization, that determines what you can actually do once you're inside. It's basically the difference between simply walking through the front door of an office building because you have a standard employee badge versus having the highly restricted specialized admin access required to actually enter the server room.
Section 2. Why AI engineers need IAM.
It's fascinating just how heavily AI engineers rely on these exact principles every single day. Think about this for a second. What actually happens to an AI application if it lacks the proper authorization? Well, if permissions are missing, your APIs get blocked, and those really expensive GPU training jobs, they're going to fail, sometimes after hours of compute time. But honestly, if permissions are overly broad, that's even worse. A single, tiny misconfigured policy could easily expose sensitive, personally identifiable information. We're talking financial records or medical data sitting right there in your S3 training datasets to the public internet. No one wants that.
So, the really crucial point here is that AI engineers interact with incredibly powerful data-heavy services all the time. S3 for datasets, SageMaker for model training, generative AI on Amazon Bedrock, EC2 for heavy GPU workloads, and Lambda for automation functions. All of these require incredibly secure access. To interact with literally any of these tools, an application absolutely must have secure, perfectly configured access governed entirely by IAM.
Moving on to Section 3. Users and groups explained.
Let's look at our first building blocks and see how we actually build a security profile for humans. An IAM user represents an individual person or an application that needs to log into AWS. Maybe it's a new ML engineer joining your team, or just a simple backend script making API calls. But here's the most crucial detail. A brand new IAM user has absolutely zero permissions by default. I mean, nothing. This is AWS's incredibly strict security-first approach. If you create a brand new user named AI_engineer, they can't do a single thing in your account until you explicitly attach a policy that grants them permission.
But let's be real, managing users one by one, total nightmare, especially as your team grows. And that's exactly why we use IAM Groups. The workflow is super simple. Step 1, create a logical group, let's call it data scientists. Step 2, attach the specific permissions needed for that role directly to the group itself. Step 3, simply drop your users into that group and boom, they automatically inherit all of those permissions. It saves a ton of time, it scales beautifully, and it keeps your overall access management incredibly clean.
Section 4. Policies and least privilege. All right, let's dive into the actual rulebooks that give those users and groups their power. We're talking about policies. Now, policies are just JSON documents that define what is allowed or denied. And don't let the JSON format intimidate you. I promise it's actually really straightforward. A policy is basically just 3 simple buckets. First, the effect. Does this policy allow or explicitly deny? Second, the action. What specific AWS operation is permitted, like reading a file using S3 getObject? And third, the resource. Which exact AWS asset is being targeted? For example, a very specific S3 bucket holding your machine learning data.
And that level of precision leads us directly to this quote, which is the absolute golden rule of AWS security, the least privilege principle. You must grant the absolute minimum permissions required to do the job. Nothing more. If a user only needs to read a dataset, do not give them write access. Following this simple rule prevents catastrophic mistakes, ensuring, for instance, that your new intern doesn't accidentally delete your production database or totally overwrite a newly trained model.
Section 5. The power of IAM roles. So we've covered human access, but what about machine access? This is where things get really fascinating for AI engineers. IAM users, as we discussed, have permanent credentials, passwords, access keys, things designed for humans. But AWS services, like an EC2 instance or a Lambda function, well, they don't have passwords. They can't just type into a login screen like we do. Instead, they need a temporary guest badge to do their work securely. And that is exactly what an IAM role is. Temporary, automatically rotating security credentials that a service can simply assume.
Let's walk through a real-world AI workflow just to see how seamlessly this all comes together. Say a SageMaker training job is launched. Right away, SageMaker assumes a specific execution role assigned to it. This role holds a policy granting SageMaker temporary permission to read training data from an S3 bucket and then write the final model back. Once the training job is complete, those temporary credentials automatically expire. It is incredibly secure, mostly because a static password never has to be hard-coded into your machine learning code.
Section 6. Best Practices for Production.
Okay, so how do we actually apply these concepts safely out in the wild? Here are a few absolutely essential production rules. First up, never ever embed static access keys in your code or push them to a Git repository. Honestly, hard-coded credentials leaked on GitHub can compromise an entire company in minutes. It happens all the time. Second, enforce multi-factor authentication, or MFA, for all human users. Third, just like we talked about, always use IAM roles for AWS services. No static keys for machines. Fourth, audit all your API activity using AWS CloudTrail so you know exactly who did what and when. And finally, for those really sensitive ML workloads, isolate your environments at the network level using Amazon VPC.
Okay, before we wrap up, I want you to take a look at this number. It's kind of surprising. Despite being the absolute backbone of your cloud security, AWS IAM is completely free. It doesn't matter how many users, groups, roles, or complex policies you create, it costs absolutely nothing. So really, there is zero excuse not to implement proper security controls immediately. Which leads us with one final, kind of uncomfortable question. If your AI application was compromised today, right now, would your current IAM setup contain the blast radius, or would it just hand over the master key to your entire AWS account? It's a really great reminder to go review your cloud environments, enforce that principle of least privilege we talked about, and make sure your models are built on a rock-solid foundation. Thanks so much for exploring this topic with me in today's Explainer. Catch you next time.